All
Okay.
right.
Hi, guys.
Yeah.
It's recording. Mitchell, have you done the homework at all?
I've worked on some of it. I think I've got like half of it all like completely done, and then the other two I'm like semi done.
Yeah. I still have I've done the first two, but not the other two.
Okay.
Okay.
But I did kind of look over like the graphs and stuff because I was like the preparation thing.
Uh-huh.
Yeah. So, okay. So let's start with the extension problems. So it says graph the following functions. Be sure to identify all 5 transformations, plot at least one period. This will be done with the 5 important points, and identify the domain and range. So f of x is 1/2 sine of 2x minus pi minus 1. So I think the first thing you have to do is you have to factor out the 2 so that it's just x minus pi. Or it would be x pi divided by 2.
Oh, okay. So it'd be 1/2 sine 2.
And then in parentheses 2, and then in parentheses x minus pi over 2 minus 1.
Okay, so you have 2 parentheses then.
Yeah.
1/2 sine parentheses 2 parentheses x minus pi over 2
Parentheses minus 1. And then so I think the period is pi because that's what it was before we factored it out. And then we have to break that up into 4 sections. So like, let's just do the transformations first, I guess. So period, and then shrink is 1/2.
1/2.
It doesn't, there's no reflection because it's not negative.
And then it moves down 1, right?
Yeah, down 1, and then to the right, pi over 2. So then on our graph, we have to do this is kind of where I get confused about how to, because it's pi. So like at the first one, we'll have to do the x-axis would be pi over 4, right? It's 1/4.
I'm gonna run the restroom real quick, 1 second.
Okay. So that's what I got, sort of what the graph would look like. Not really though.
Okay. So when you're doing when you start out with a half sign, the beginning thing, are you trying to. I didn't hear what you and Mitchell were saying. Do you distribute that half over into
No,
that?
that the half is the shrink.
Oh,
The
sorry.
shrink is stretch.
Is it just kind of like the setup how before we had like the different things, we already knew what they were?
Yeah, so like if you, yeah, these are exactly the same, except for now you just have to add a period, the period, so how long it takes for the like the waves to kind of go.
Okay.
But yeah, everything else is the same, like moving it to the right is the same, down, and then that the shrink or the stretch, and then if it's negative then it's reflected, and
Okay.
so it like goes opposite.
All right. So then how do you figure out, I guess, that wave?
So I guess it would help if you like just did the normal graph, and there's like little videos that you can help. So it's just let's see. So pretty much like if you did the parent graph, it starts at 0, 0.
Okay.
So for sine, I think it starts at 1. No, sine starts at 0, and then it pretty much just skips like 1 on the x-axis. Like, let me see if I have my notes.
Okay.
I don't know if you can see. So like when you start at 0, and then it skips 1 and then goes to the other one, but like in a wave kind of format.
So that the top of that, like where you have that 3, yeah, that y equals 3 sine x. How do you find that I guess the top of that wave and the bottom of that wave?
So the 3 is the stretch. So that just means that instead of going to 1, it's going up to 3.
Okay.
And you can just label your graph however that stretches.
All right.
Okay, so are you guys good with graphing that, or
what did you what did you or what did it look like again? I'm sorry.
it's a rough scrap, but kind of like that.
Okay, so you did every period. So the period was pi, right?
And then I did starting from there. I did 1/4 pi, 1/2 pi, 3 pi over 4, and then pi.
Okay, because it shifts over half, right?
Yeah, so you just break that up into fourths.
Okay. And then the shrink by 1/2, is that just how high it goes?
I think that's where the first point is. Like I did my 1 really big, but I think I just did 1 point there about half. And then it goes down to 1. I did that one a little lower, but it should be like right there.
Oh, okay. Okay, that makes sense.
Because it just moved down 1, so then it's not going to be like going over the x-axis, but down and over, like down.
Yeah. So since it shifts over pi over half or pi over 2, where it technically starts instead of 0, it starts at pi over 2, right?
Yes.
Okay. So it'd be 0 pi over 2, and then it would go up to.
And then shift down 1, so then it would be pi over 2 negative 1.
Okay. And then the next point would be 0 pi over.
I think the next point would be 0 pi.
Okay, and
But
then
it
next
kind of
was
always skips, like there's one line in between the wave.
yeah, and then -1, or it'd be 3 pi over, or 3 pi over 4, right? Or 3
Yeah.
pi over 2.
I don't know. I just graphed it to pi because I get them confused, and I just know those four.
Okay, no worries. I understand where you're coming from.
Yeah.
But we got all the transformations, right?
Yeah. So
And then
period, string,
oh, I'm sorry.
write down, and no reflection.
Okay, no reflection.
Oh.
So, and then domain was, is it -infinity to infinity?
Yes.
And then the range is from, is it -1 to 0?
I think it would be negative 0.5 because it shrunk, right? Let me look.
Well, it has to be at least to -1, right? Because if it shifted down.
But that's kind of where it starts, so it will go up and below that by half. So I guess it would go 1/2, and then and then a 1.5, right? Because since it shrunk down to, it's kind of, that range is going to be either 1/2, and then one is like the new x-axis, sorry, and then it would go down to 1.5.
Okay, so we would say from -1.5 to -0.5.
Yeah,
Okay.
that's what I would think. But does someone have the answer keys though?
Yeah, I can check. Let's see. So period is pi, no reflection over x-axis, shrink by 1/2. To the right, pi over 2, down 1. Domain is all real numbers, and range is from -1.5 to -1/2.
Cool.
So yeah. So in this case, so if there's since that 2 is in the parentheses, do you always have to pull that out?
That's what I understood from the the little preparation things that I watched. It says to always pull it out because then it will make the pi over 3 or pi over 2 that you need versus a number.
Oh, okay, I get you. And then that'll give you your shift.
Yeah.
Right or left.
So it always does that, and then you take that and then you divide the graph into the 4 equal parts so that you can get the the wave.
Uh-huh.
So
okay, that makes
that's
sense.
just what I understood from the reading. So I don't know if there's an easier way or not, but
okay, cool.
okay. So then the second one is -4. How do you say cosine when it's the COS?
Yeah, I say cosine.
Cosine, okay. And then 3x plus pi parentheses plus 5. So
Okay, so you pull the 3 out of this first as well, right?
yeah.
Then you get -4 cosine parentheses 3, and then parentheses x plus pi over 3 plus 5.
Okay, I think it worked out on the first one, but I think the period actually just reminded me. I think you take the coefficient up before the sign, and you have to times it by. So, like, I don't know if you can see, like on this one where it's -2, and then the period ended up being 2 pi over 3. So like timesing 2 times pi over 3.
Yeah.
And I think it just worked out on the other one because the 1/2, but I think this period is going to be different.
Okay, so the period is the coefficient multiplied by the...
Oh, because it's 2 pi over b. And so once we get this pulled out, then... Okay, I get it now. So it's 2 pi over b. It doesn't have anything to do with that, I don't think.
Oh, that's the actual equation.
Yeah, so it's actually... So the equation is 2 pi over b, so it would be 2 pi over... And b is 3. Because we pulled it out and made the equation match.
Oh, okay.
So then it's your period would be 2 pi over 3 because of that equation.
Okay, so your b is whatever whatever you pull out.
Of the the 3x plus pi.
Okay, so since the last, so like just for example, sorry, so we had 2 pi over 2, so it'd bring it down to pi.
Yeah, because then the 2's cancel out and it's just pi.
Okay, that makes sense. So, okay, so the period is 2 pi over 3.
And then it's reflected.
The x-axis.
To the left, pi thirds.
And up 5. And a stretch.
Let me say there's one more.
Stretch of 4.
Okay, I need a graph. So I always put 4 lines and then the 4th one I do the period. I don't know if that's the right way to do it.
I feel like that would be the easiest way.
Right? Like where you just do 4 and then that's your period. Is that...
That's where it completes a full, like, I don't want to say rotation, but it completes a full cycle.
Yeah. And then since it goes up to 5, I guess we need to... I guess where I get confused is how do you break that down after that? Is it just by force, I guess?
Break down.
Like the next, like where you have to label. So the next line over would be pi over 2, I guess?
Well, so if we have our period in 2 pi over 3 and we're going to the left pi over 3, we'd want to keep it in thirds. So what it would be is, so if you were to do, so we know the 4th one is going to be 2 pi over 3. The second one's going to be half that, so it's going to be pi over 3. And then we're going to do half of that, so it'd be pi over 6.
Okay.
And then half, or...
No, I think we're missing one, right?
Yeah, the third one. I was just doing this first.
Oh, you did it backwards. Okay. I see.
So this one would be... how do you convert that? Or how do you change that? I guess it would be 3 pi over 6, which would technically just be pi over 2.
Okay.
I mean, I'm going to keep it as 3 pi over 6 just so it's easier.
And then
so we're going to go up 5. 1, 2, 3, 4. And it's going to shift pi
thirds. Since it's stretched by negative 4, I guess it would be the new bottom of it would be 1, right?
Say that again. I'm sorry.
Oh, since it stretches by negative 4, so it's going to go down to 1, and then over. So I think our first point would be on the negative side.
Okay.
Right? Since it stretches down, it's not going to ever touch the x-axis.
Yeah. Sorry, I'm trying to like process what you're saying.
Oh, you're good.
So the new.
So I don't think it's going to ever touch the x-axis because it shrinks down 4, but it moved up 1. So I think our range is going to be
Oh, okay. I think I get what you're saying. It's
1
because.
and then 4 above that, so 9. 1 and 9.
Oh, yes. Okay, I get what you're saying now.
Yeah.
So it shifted up 5, but since the stretch is 4, that's just what the amplitude's going to be, right?
Yeah.
Oh, okay. But it's going to be times 2.
Times 2.
Or I mean, okay, I get what I'm saying is, since it's 4, it reaches, so it goes up by 4, and then it comes below at 4. So technically it's 8 units, but your range is going to be within 8. So from 1 to 9.
Oh, yeah.
Okay, that's what I was trying to make sense with.
I don't know if this is right, but I think it would be something like this where it goes down and then up to 9, and then because that's the new like x-axis, and then down back to 1 on the other side to match that one.
Okay, where did you plot your second points? Over the pi over 6. What did those? It's just they're halfway in between, right?
Yeah, so I think that would be on the 5. I kind of skipped that one, but
Okay, so both those on the 5, and then what was
the next one would be up to 9 since it goes reflect like you have to go on the other side of x, so then it would be up to 9. And then I didn't really graph this nicely, but and then pi third would be back to the 1, so pi third 1, and then
what was your middle point? Is it just 0, 9?
0, 9.
Okay.
If you kept going, it would be oh, my graph's not very nice, but I think it would be like
Yeah. And the domain for this is from negative infinity to infinity, correct?
mm-hmm.
And the range is from 1 to 9.
Yes. That's what I got.
Okay. Double check the answers here. Period 2 pi over 3. Reflect over the x-axis. Stretch by 4. Left pi over 3. And then up 5. Domain is all real numbers. And the range is from 1 to 9, including those points.
Cool.
Cool. Alrighty, so number 2. So the transformational form for the 4 additional functions is the same as before. The difference is that the tangent and the cotangent functions have a period of pi and not pi 2 and not have a period of pi and not pi 2 and not pi 2 like the other functions.
That's the same thing, right?
I don't know. Maybe she wrote that twice. The 4 additional functions have asymptotes.
Plot the parent functions.
And it says identify the domain and range for all 6 parent functions.
Oh, fun.
So tangent.
So tan x. Well, this kind of makes it nicer because the periods are just pi, right?
Yeah.
So then it's just. Wouldn't that make the asymptotes on pi and negative pi? I don't know.
So you're saying pi and negative pi?
Yeah, I'm not sure. This is kind of where I kind of need to look into more.
Let me see.
Oh no, I wouldn't have the isotopes. I think that's where it goes through. So I'm gonna pull up the book real fast.
Yeah, I'll pull it up as well. Trigonometry. Oh, okay. So tangent is sine over cosine, right? So in this case, so the denominator, so the asymptote would be where cosine equals 0, because you can't have a 0 in the denominator, right?
Yeah.
So when does cosine equal 0?
Um, I don't know if it does because the graphs always start at, like if it's over just like a unit, 1, it always starts at 1 and then goes down.
Okay, so when does it go through the x-axis? At pi, it's at a certain point, right?
Like you mean the y-axis?
So so it starts at 1 and then it goes down, and what point does it go through on the x-axis?
Sorry, my example I have is just it had a stretch of 2, so then it was pi over 8. So
Okay, I'm just saying just cosine in general.
Oh, I don't know.
Well, so the periods for cosine and sine is 2 pi, right?
Yes.
So what it would have to be is it would start at 0, or it'd start at 1 or 0, 1, and then it would have to come down, go through, would it be pi? Does it go through pi? Let me see what a cosine function looks like.
By pi, it would be half pi over 2, right?
Pi over 2 is what you're saying? It goes through pi over 2?
I think so.
Let's see here, cosine function. So it goes through pi over 2. So that's where x equals 0.
Yes.
So what that would have to mean is that cosine of x cannot be pi over 2, because that would equal 0, and that would be in the denominator would equal 0.
Okay.
Does that make sense? So your asymptotes would be, it would have to be any multiple, or I guess, yeah, it would have to be any multiple with pi over 2. Does that make sense?
Yeah.
So it would be asymptotes of pi over 2, 3 pi over 2, 5 pi over 2, and so on.
That's where all the asymptotes are?
Yeah. And then since the tangent goes through.
Oh, I see what you're saying. I'm sorry.
Is it making more sense to you?
Yeah. So the asymptotes are the pi over 2 and then the multiples of that.
Yes.
Okay, and they're vertical, right?
Yes.
Since it's the opposite.
Yeah. So what did it say? So it said, part of the example, so it says identify the domain and range for all 6 parent functions, and identify the period for all of them. So for this one, the period was pi, and then the domain would be
I think it's one of those where it's like x is all x's except for x that's not over the asymptotes, right?
Yeah. So what you could write it as is it would be x cannot equal pi over 2, and then you could just put it and then add or plus pi to the
X? Or I guess the coefficient.
yeah. So what would, I don't know, let's use like t, or I don't know, just a variable.
The variable.
Because the pi variable would be.
Would it be k?
Yeah, you would use k.
Okay.
Because so the plus pi k is what would give you those multiples. Does that make sense?
Mm-hmm. Yeah, that does.
And the range would be from
All
negative infinity to infinity, so all real numbers.
And then does it say we need to graph it too?
No. Thank goodness. Oh, we have to do the other two as well. So sine and cosine. So it said identify the domain and range for all 6 apparent functions. So for sine,
No, isn't it it says plot the parent function of each function. So there's y equals tan, y equals what, COT. So one, oh, so that's only 4. So yeah, we have to do the other ones.
oh, so we do have to graph them.
Yeah, this is plot them.
Oh.
But I think that's easy because I think since there's no numbers, it just goes through like 1, 0, and then 1.
Yeah, so it goes through 0 and it goes through pi, but then you have asymptotes in between those.
So like kind of like that.
Yeah. Yes, exactly like that.
Oh, sorry.
Okay, and then we have to do the other word. So we know what the other ones look like, right? Are we kind of good on those? Or,
What the like the,
cosine. That's what I meant. Sine and cosine.
oh yeah.
Okay. Because sine starts at 0, goes up to 1.
No. Like a wave.
Yeah. And then the period for that is 2 pi, right? So it goes through pi.
Yeah.
And then cosine, it just starts at 1, goes through pi, and then to 2 pi again, right?
Yes.
Okay. Are you good on that, Antonio?
When you say it starts at 1, is it 0, 1, or
0,
sorry, 1? So the 1 would be the x or on the y?
The y.
Okay, that's what I thought. I just wanted to make sure. I've been sorry, I'm not much help. I've just kind of been reviewing how it shifts and all that, so I'm starting to pick it up a little more.
Okay, no worries. So now the next one was cotangent. The cotangent is just the I don't want to say I don't want to say it's the inverse, right?
Yeah.
It's just the opposite. So instead of it being sine over cosine, it would be cosine over sine.
Okay. So I'm just trying to notes. That part was really confusing to me for some reason. Cotangent was 1 over tangent.
Yeah, so if it's 1 divided by technically sine over cosine, it would just multiply. So it'd be cosine over sine.
Okay.
So I write it in terms of cosine and sine just because it makes it a little bit easier to understand.
Okay.
So it's cosine over sine. And then so this is the same situation where we have to figure out, or we have to know where sine equals, where x equals 0 for sine.
Yeah. Sorry, I'm just looking up what 2.
So for a sine function, if I was to remember, is it goes through pi and it goes over 2 over pi. So when x equals 0, it's pi.
Okay.
So what the asymptote would be is that it cannot equal, or it cannot have pi, and so x cannot equal any coefficient with pi in it. So any multiple of pi.
So what do you write it just like x equals slash and then pi k?
Yeah,
Or
or
do you
k
pi?
pi.
Okay.
And then the period for this one would still be pi, since tangent was still pi. You would still keep that the same.
But
And
our
then,
asymptote is on pi.
yeah. And then our domain would be x cannot equal, like the last one was any k pi, or pi k, whatever you write as. And then the range would be all real numbers.
And then the graph would go opposite, right? Since it's dividing. So instead of going to the up to the right, it goes to the left.
Yeah.
Okay. And then next one is what does SEC mean?
SEC, so that's the arc sine. So SEC, so that's 1 over sine.
1 over sine.
Yeah, so that's what it means. So SE is 1 over sine.
So these are going to have a lot more asymptotes, right?
Yeah.
Just because they're fractions. So I think it would be the same as it'd be the pi over 2, right? That same thing where it's pi over 2 and then
Yeah, because sine of x equals sine at pi over 2. Right?
yeah, I think it's that because and then but there's gonna be no, I think the asymptotes will be the same, and then I think the parent function is going to be different since it's a fraction.
Yeah, so they won't be connected. Since they'll be asymptotes, it just kind of there'll be a couple like parabolas is what they'll look like. That's what I remember from high school.
Okay.
What did we say the asymptotes were? When did sine equal 0?
Oh, but it's the asymptotes for oh, sorry. I think it's the same as that first one we did where the asymptote was that pi over 2.
Okay.
And then the multiples of it. But I could be wrong.
trying to remember here. Yeah, because sine cannot equal. When did sine equal 0?
Oh, sorry.
It was when it went through pi, correct?
Yeah.
So then why wouldn't it be? That's what I'm not understanding here. So if it's sine, so sine of, oh, goodness, why can't I speak?
So it's per, oh,
So pi over 2. So you're saying pi over 2 would be the asymptote again?
just remember sine and do that for the one. So I'm just trying to find it in the book. Feels like this book is not very helpful right now.
Oh, I'm sorry. I had them switched. SEC is 1 over cosine. That's why it's not making sense.
Oh, okay.
I remember getting these messed up because I thought SEC was 1 over sine because it was just like SEC looked like sine and then CSC looked like cosine.
Yeah.
But they're actually flipped. Yeah.
That's not very nice. They should change that.
All right. That's why. Okay, so now everything makes sense now. Because I was trying to figure it out. I was like, it doesn't go through 0 at pi over 2 for sine, but cosine does. Because it starts at 0, 1, and it comes down, goes through pi over 2, and then we'll come back up again at 3 pi over 2, and then complete it at 2 pi.
Oh, that's
So,
for.
Yeah. Does that make sense?
Yeah, that does.
Yeah, so the period for these ones is 2 pi. And then, so your domain, so you could not equal pi over 2 plus pi k, any multiples of that.
Okay.
And then your range, so since this is 1 over, so what that means is, so like I was saying, is that there's going to be a bunch of parabolas. So they just flip. So if you just put the asymptotes down first, so every pi over 2 is an asymptote. So pi over 2, pi over 2. So in the first part, in the middle, so since it starts at 1, in cosine it would go down, right? So it comes like that, like an upside down parabola.
Okay.
Then this one you'd flip it so it goes up.
Okay, so it goes up between the two asymptotes.
Yeah. So it still comes down and starts at, it touches 1, but then it goes back up. And then the other two in the next like sections and then over the next asymptotes. So these ones are upside down parabolas, but they'll come up to -1.
Okay.
And then but then turn around and come back down.
Okay.
So like that, if you can see that.
Oh yeah. Okay. That makes sense.
So the ranges for these ones would be, so it would be from -infinity and it can still come up to -1, including that. And then you'd have a u, and then you would have another, so it'd be, and then it would go from 1 to infinity.
Okay.
So you'd have brackets on the ones, on the negative one and the one.
Okay, that makes sense.
Does that make sense, Antonio? Is it kind of coming back a little bit more?
Yeah, I'm still kind of trying to remember it, but yeah, it's coming back a little bit.
Okay. I mean, just let me know if you have questions or anything like that, because I mean, I'm starting to get this. It's starting to come back to me.
Okay.
So
I actually I do have a question because I couldn't find anywhere. I've been looking everywhere for that what you guys been talking about, like tangent equals sine over cosine. Like I don't know what they are, uh, all those things.
oh, okay.
So I haven't been able to follow along in that sense.
Okay, so they're all in the book, but I can tell you right here real quick if you want to write them down.
Oh yeah, yeah.
So tangent is sine over cosine.
Okay.
Cotangent is going to be cosine over sine. So that one's easy to remember. So the cotangent, the arc cosine, and the arc sine, they're all going to be reciprocals of what the originals were.
Oh, okay.
So do you see the kind of the relationship between tangent and cotangent? How it's just flipped for cotangent?
Yeah.
So
That's easy to remember then.
yeah. So SEC.
SCC.
SEC. Sorry.
Oh, SCK.
So like
Okay.
sec is
Right.
going to be 1 over cosine.
1 cosine. Okay.
And then CSC is going to be 1 over sine.
Oh, okay.
Does that make sense?
Yeah.
Give me 1 second here. I got to go check on something.
Is it just those 4, Monique?
So those ones, and then you have cosine and sine,
Oh,
which are. I have it written down. Sorry. So this part confuses me because I didn't take this in high school, and besides that, high school is forever ago.
yeah. I know I have. When we were packing, I remember seeing my notes for all of this, and I didn't put them aside so I could have them. And I'm still trying to find all of that because I noticed that we're doing this.
Yeah.
So I thought, oh, it'll be an easy review, but I can't remember any of it right now.
Yeah, I can't. I don't think cosine and sine have like the same thing. I think it's based on the angles. So like the adjacent angle. Why can't I find that?
Did you do the next one already or no?
No, so he was just asking, so we have the 4 and then the other 2 are the cosine and sine, but do you remember what those are? Is it like the adjacent and the hypo?
Yeah. I'm trying to, so let me see. So I'm trying to SOHCAHTOA. So sine is going to be opposite over hypothesis. And then cosine is going to be adjacent over hypothesis. SOHCAHTOA. And then tangent is going to be opposite over adjacent.
What was that last one again? Sorry.
Tangent, so it's opposite over adjacent.
Opposite. Adjacent. Okay.
I couldn't find it in my notes. Okay, so then the CSC is 1 over sine.
Yeah, so CSC is 1 over sine. So this one is the same as the cotangent. So x cannot equal pi k.
Okay.
And then the period for this one would be 2 pi.
Sorry, what was it?
2 pi.
Okay.
Since these are sine and cosines,
Oh,
but just
right.
like the opposite, they'll still complete, or technically complete one for 2 pi's. And then, so if we graph this one, so if you just graph it real quick and do the asymptotes.
Am I crazy, or does it look like the same as the other one we just did?
No, it's going to look the exact same. It's just going to look like a sine.
Okay.
It looks just like that. Or where'd it go?
Okay.
So if you just like think about it, so like for these ones, so the 1 over cosine, the 1 over sine. So since they're going to be, I don't want to say they're inverses, but okay, so since they're reciprocals, you just kind of have to imagine where they connect at the 0. They're just going to flip.
Okay.
Do you know where every arc, so like this is so like a sine or a cosine, they look like that. They're just gonna go like that.
Oh, okay.
They're just gonna break apart and they're gonna flip the other way.
Okay.
So the domain for this one is, so x cannot equal pi k, and the range would be the same as the arc cosine. So it can come up to -infinity to -1 bracket u, and then bracket 1 to infinity.
Okay. Cool.
Alrighty. And that's it for the extension problems, correct?
Yes.
Nice.
Good job. Thanks for
That
helping
wasn't
us.
too bad.
So then let's do the quiz real fast. And
How long was the quiz? Did you guys already look at it?
I think it was only like 2 questions. It wasn't very long.
Okay.
Let me get to.
Okay, I see.
Oh, my computer's being so slow.
Zoom in.
Mitchell, do you want to turn the quiz in for this one?
Yeah, I can do it.
Since you have the best graphs and knowledge of this one.
Honestly, like, I mean, for the most part, I honestly just picked this all up while we were doing it. But a lot of it just like came back to me like as we were doing it from high school. So, I mean, I'm probably still on the same level.
You're closer to high school, though.
I guess so. Okay, so this one says, so list the transformations made to the cosine function and write an equation of the form y equals a cosine b x minus c plus d, whose graph is given the cosine
So I have to
function.
look at the graph and then come up with the equation.
Yeah.
Okay.
Alrighty, so I think the best way to do this would be just to figure out what the transformations are first.
Yeah.
And then just write it. So this one, so the first thing I can see right off the bat is that it shifts over 3 pi over 2.
Mm-hmm.
So it shifts to the right. I'm just gonna write these down. So shifts to right 3 pi over 2, and then it moves up
It's
4.
5. No, 5 or 4?
4, because cosine starts at 0, 1, remember?
Oh, yeah. Thank you.
No worries. Shift up 4. Alrighty, and then
It's not reflected.
it's not reflected. What is the period? We need to know what the period is.
3 pi? Because it goes from 0 to 3 pi?
Yes, I think. Well, what was it? What was the equation for period again? It was 2 pi over b.
2 pi over 2. No, sorry, I wrote it down and I forgot. 2 pi over b.
Okay. So a period would have to be when it completes the entire thing, not the thing, and completes a full cycle.
Mm-hmm.
So
I need to work backwards then, so.
well, I guess so. Let's say this. So if it starts at 3 pi over 2, then that would mean it would complete its cycle again in it would be twice that, right? Or
Yes, because that's just 1, so then the next one would be
so it'd be 6 pi over 2,
pi
right?
over 2. Which would be, I don't know if we have to simplify it. So if it's 6 pi over 2, and we,
That would just mean 3 pi.
yeah.
But if you look at 3 pi, it doesn't even that's when it comes down. Or it's like close to that. You see that?
Mm-hmm.
I mean, it looks like there's it kind of looks like there's a stretch, right?
Yeah, I think because it goes down to -1.
Yeah, so it touches the -1. So instead of it being 1, the stretch would be, so if it goes from -1 to 5, that would mean 6. So it'd be stretched by 3.
I don't think it's 3.
Because usually for a cosine, the stretch is from it's 1, right?
Uh-huh.
So for this one, since the highest it goes up to is 5, and then lowest is goes to -1. So there's 6 units so there's 6 units total from the maximum to the minimum. So if you did half of that, that would be 3.
Yeah, I see what you're saying. Yeah, I think that's
Okay, so it'd be a stretch by 3 then, right?
by 3, yeah. So 3 cosine, and then b.
Well, so if we know what b is, then we can figure out what the period is then, right?
Yeah.
So what was the equation again?
2 pi over b.
So it'd be 2 pi thirds? Is that correct?
2 pi thirds. Well, wouldn't it be, since we simplified that down to 3 pi, wouldn't b be 2?
Oh, A equals 3, right? Is that what you were saying?
Yeah, I think a is 3 because that's
Oh,
the
okay.
stretch.
Yeah, I was thinking the stretch was B for some reason. I'm sorry.
Oh, you're good.
So what I have so far is 3 cosine.
Parenthesis. That's what I have.
And then well, if it's shifted over, so then so we don't have B, but it would be x minus 3 pi over 2, right?
Yes.
And then plus 4.
4.
So the only thing here is we just have to figure out what B is. But I think what you were saying may be right, and I'm just not listening to you.
Well, I don't listen to me. I'm not. It's not my strong suit over here. We just do algebra to figure out if we did 3 pi over 2 equals 2 pi over x and figure it out. Would that work?
What were you saying? I'm sorry.
Oh, I'm just wondering if we could figure it out by like just algebra. If we did like 3 pi over 2, and then 2 pi over x and solve for x, would that work?
I mean,
Figure it out.
That easy. Let me see if I can, because we can use the book, right?
Mm-hmm.
Yeah, you can.
I think it's 3. No, don't listen to me.
And
Tony, you got any ideas, possibly?
I'm not sure. You guys. So, I know that we're trying to find that B, but in the period form as a 2 pi over B, but how? Like I'm trying to find. I'm actually going over the books trying to see if I can find like a way to find it without knowing the B and knowing maybe everything else, but I can't find anything.
That's what I'm trying to see here too. Because if you have a shift, does that change the period at all? Like maybe that'll like give us a clue, you know?
Yeah.
But do you kind of see what I was saying before, Monique? Is that like when it comes up to the top again would be that's how big the period would be, right?
Yeah, so two tall peaks or whatever
Yeah.
would be a period.
Yeah. Oh, wait. Well, okay, so the top of the peak is at 3 pi over 2, and then the bottom of the peak is 7 pi over 2. So if we do the math for that, so 7 pi over 2 minus 3 pi over 2 is 4 pi over 2, which reduces down to 2 pi, right?
2 pi.
So if you multiply that times 2,
So 4 pi.
so 4 pi is the period. Would that make sense?
Yeah, it actually would, because there would be like 2 more sections over there before. Yeah, I think that if you continue on, and it'll make sense to me at least. So 2, 1, 2.
So would B, so is B just, so is B 4 or is it 4 pi?
So our period's 4 pi.
Yeah.
So then so if we took,
Because you could also, I guess the other way you can figure it out is that, so since there's the 2 bottom peaks on this graph, from negative pi over 2 to 7 pi over 2, if you add those and just keep it the absolute value of it, it gets you 8 pi over 2, which is 4 pi.
okay.
So the period is 4 pi.
So maybe I think we're looking at it like we need a B, but maybe we don't need a B. Right? Or do you always...
That's what I'm confused about. Is if we need to, if there is a, like, or why would you say there wouldn't be a B?
Just because if it's 4 pi, like what would you take out of 4 pi that would make it 4 pi, I guess is the question.
Oh, or what we could do is if we use,
so our period, oh no, just kidding. Our period's 4 pi. Our shift was 3 pi over 2, so we need to figure out what the 4 pi, oh my gosh, sorry, my brain's not working.
So what I was thinking too is since we have our period, we can just plug that into the equation that we have. So 4 pi equals 2 pi over B and solve for B.
Yeah.
Does that make sense?
Yes.
So if we did 4 pi equals 2 pi over B, so what we would do is we'd multiply by B on both sides. So you get B over there, and then you multiply or divide by 4 pi on both sides. So what that ends up being is B equals 2 pi over 4 pi, which turns out to be pi over 2.
Yes.
Okay, so this is what I have. So I have 3 cosine brackets pi over 2, parentheses x minus 3 pi over 2, parentheses bracket plus 4.
Yes.
Okay.
I would agree with that. Antonio, do you agree with that?
Huh?
Does anyone have a calculator on them real quick that wants to try to... That's what it turns out to be. I guess there's no... Of course there's not going to be a key.
I don't know my...
Where did my calculator go?
What should it end up when we put it in?
What should it end up? Like, what do you mean?
Like when you say put it in the calculator.
Like if you graph that function.
Oh, I don't know how to do that.
What's it? What's it? 3 cosine, and then 3x plus pi over 2, and then the plus 4. Was that correct?
No, so it's 3 cosine and then a bracket pi over 2.
Okay, hold on. Pi over 2. The bracket. Okay.
So
The only thing is, I don't think we've ever seen an example where b has been a pi, right? I mean, it doesn't mean it doesn't exist, but
Let me x minus 3 pi over 2?
yeah.
Plus 4. Okay. I'll graph that. I heard it wrong.
Okay. Yeah, just let me know and see if it looks like what we have. If we figure this out, I'm actually going to be like really happy.
while you graph that, I'm gonna be right back, okay?
Okay. See where I put my calculator still.
I'm just getting an error. I don't know what I'm doing wrong here.
Is it your parentheses maybe? That's probably just like that's
So
probably
it automatically puts a parentheses after the cosine.
right. So what you'll need to do is you'll have to put another.
Okay. The cosine is independent of everything, right?
Yes.
Or is it the cosine of all of that?
So the cosine. So what it needs to be is it needs to be the cosine of everything inside those brackets.
Okay.
So the plus 4 is going to be outside of everything. I will be right back to you. I'm trying to find my calculator still.
Okay.
Sorry. Did that work out?
He's still graphing it. I just found my calculator, so I'm going to try to do it as well.
Okay.
But if we can't get anything, then I mean, I feel like we should just keep it like that. I mean, she still gets points if we try it.
Yeah.
Not wrong, but I'm just honestly just really curious about this.
It worked out, yeah.
So 3 cosine.
What I want to do is get all of this cleaned up and this today. Get this over here, close as I can. Put all of my clean broom mops right there. And then the cleaning supplies up there.
Oh goodness, I wasn't typing.
Okay, I just got it to work. But I'm not sure where the points are.
So if you pull up the table, Antonio, so if you go to the graph button, it should pull up a table.
All right, I got it. So do you guys have an idea of what they are? The X and Y?
So let me see here. So 3 pi?
3 pi over 2, 5.
3
Yeah.
pi.
So what?
And then 3
So
pi.
3 pi over 2 is 4.712388. So do you have any x values by that?
No, so on the calculator, it only gives me like the 0, 1. It doesn't give me any pi values. So I have
What does it give you for 0?
I got 5.3097. That's what 0 is x, and then the y is 5.3097.
Okay, that's not correct then. Does your graph look like the one on the quiz?
Let me see.
And I only have like 3 things: broom and a mop.
Let me see if I can zoom in this thing.
Okay, I really don't think we're gonna have a lot of trick-or-treaters with the candy that we have in the house already. Yeah, there's no kids here. This is all an adult place. We don't even have a couple bags. Candy you have in the house is like, well, they were candy bars. We'll go buy some.
No, it looks the starting point is not by 0.
Just saying.
It looks like this. I'll show you on the. So the x maximum of that is 5, and it's nowhere near that 0.
Okay, so then that one's not right. So let me see here real quick. Wait, I needed 11 pi divided by 2. No, my x max needs to be goodness gracious, Mitchell.
Could it be 6? Try having, instead of pi 2, having it be 6. And see what that does. Can you do that?
Instead of that pi over 2.
Yeah. Have B be
All right.
6.
Let me see.
What is my window range? Oh, that's fine.
It's definitely closer, but it's not. That's what you get then.
What's your your range? Like, can you make it spread out more, or I don't know how that works. Sorry.
Well, I just have the. So the only thing I changed on that was the pi over 2, so everything else is the same. I don't. Which one is the range? I forget. Is it the?
The range is your y min and your y max.
Oh, you. Let me see. Oh.
Oh, I think actually, Antonia, try one more thing. Try it being 1/2 instead of pi over 2. So when we saw for b, we didn't cancel out the pi's.
Oh.
So we thought it was pi over 2, but what it really is 1/2.
Let me.
So see if 1/2 makes a difference. Do you see where that makes sense though, Monique?
Yeah, that we didn't cancel out the pies.
Yeah.
So it let me see real quick. It goes over 5. So it doesn't. Let me increase the window. So the window you'll see is only 5. Let me see. Okay. It's plotting now. So that's what it is.
That's what you got when you put in 1/2.
Yeah.
Okay, crap. Oh, shoot.
Let's see.
Cosine.
Did we try 1/4?
One
Sorry to make you keep trying, but we did
one
1/4.
1/4 instead of the 1/2.
Uh-huh.
It's actually an easy change. Let's see. Oh, where'd it go? It looks like a line now. I don't think that's right.
Adding the 1/4.
Okay, I got a graph that looks a little bit closer.
Oh, it's way bigger. With 1/4, it's way bigger.
Okay.
So our minus 3 pi over 2 is correct though, right? I'm just trying to make sure all of our transformations are correct as well. So it shifted over 3 pi over 2.
Is it supposed to be minus 3 pi over 2 though? Or I don't remember. Is it?
Yeah, it should be minus 3 pi since it went to the right.
Yeah.
Okay. Okay.
And then it goes up 4. And then the stretch.
But it wouldn't go up 4 because their stretch is at 3. So really it only.
You think that may be it?
Maybe. Right? Because if the stretch is there, that would be our new x.
So if you do it without the stretch, it doesn't.
Doesn't look like it at all.
only touches 3. Or it only the highest it goes up to is 3.
So you try. Try having DB2. Is that possible to do a graph with D being 2?
Let me see.
Since
Ooh, I think you're right, Monique. I think I just did the 2, and let me see here. So for 0, I got negative 0.1213, which looks very close to where that is.
uh-huh.
So let me see. So Antonio, do you want to real quick input 3 pi over 2 into that equation and see what it comes out with?
Wait, hold on. The what?
So don't graph it. Just do the equation on your calculator and input 3 pi over 2 for x and see if that comes out with 5.
3 pi over 2 for x.
Yeah.
So just solve the equation or graph it?
Yeah, just solve the equation.
Okay, so let's see. So everything else is the same, right?
Yeah, just make the d plus 2. Like
well, I've been trying. I was trying different ways to graph it, and I actually changed. I used 3 cosine 1/2, and then at the end I put the plus 2, and I'm trying to figure out if that's right or not. But
Yes.
it does look it.
That's what Monique said. So I'm just trying to see if you actually input 3 pi over 2.
It looks like that, but I don't know. I'm trying to figure out if it's
It actually
close.
looks like,
Yeah, it looks really close, but I'm trying to figure out if the points are right or not. Because I've been trying to see if pi is there or not, but I need an actual like number.
Well, okay, actually this would make sense. So if we inputted 3 pi over 2, so that gives us in the middle is x, so there would be 0 times 0.5, which is 0. So the cosine of 0 is 1. 1 times 3 is 3 plus 2 is 5. So I think you were right, Monique. Yeah, what you said makes sense.
yeah.
Where did you get the plus 2 from?
So I just looked on one of the other examples that we did where it was a stretch, and it was a stretch of half, but it was -1, and it all went past that. So then I said our stretch was 3, right? So then I just counted up to 3, and that became the new x-axis, and that's what I did. I didn't do anything fancy. Then everything else is going up and over past that point.
I'm trying to follow what you're saying. Because what you got it. Like this is the right answer.
Yeah. So what I did was so I used this one where we did where it was a -1, right? And then since it was -1, but then the stretch was half, but everything went up and over that 1. So then that became the new x-axis. Is how. So then since we knew our stretch was 3, right?
Yeah.
So then I just counted from the bottom, and I went 1, 2, 3, and then it was 2, and then I just looked to see if that made sense with the way the graph was going.
Okay. I mean, I'm just trying to
I don't know if that works all the time, but
yeah, I mean, I'm just trying to personally understand what you're saying, but I mean,
and it's the same with the other one too, because it was a stretch of 4. So on our extension problem,
Yeah.
It was a stretch of 4, but it was plus 5. So everything went up, and so below 4 and up above. Sorry, it was a stretch of 4, so it was below that, so it was 1, and then it also went above it, so it was 9.
Yeah.
So everything went up and above that. So then that was the 5. Does that make more sense?
I mean, I get, yeah. I think I'm not.
Because that was like the main point where everything, like the stretch went up 5 above and then 5 below that.
Yeah. I'm just going to review the textbook. I'm not going to question you.
No, do question me because I don't know if that's right. I'm just looking at all the examples we've done and trying to apply it to what this is.
Okay, so I'm trying to look here again. So number 2 is the easiest to look at. So we had a stretch by -4.
And then it went up 5 units.
Uh-huh.
So the 5 units, I look at it as the new like x-axis.
Yeah, so originally it would be 0, 5.
Yeah.
Okay.
And then when we did our stretch, we went 4 above 5, which was 9. And then 4 below 5, which was 1.
Oh, okay. Yeah. I think I get what you're saying. So then for this one, so since it went up 2, but then it had a stretch of 3, so that would mean it would go up to 5, and then it would go
Down
3
to -1.
Oh, okay. Yes. That makes sense now. Okay. Good job, Monique. You saved us.
I did something.
Got it. Okay. So find sine of A given that cosine equals 2 over 5 and sine of A is less than 0. So cosine of A equals 2 over 5. Sine of A is less than 0. So let me see here real quick because I'm kind of interested in this. So GHOA. So if cosine is adjacent over hypotenuse. So 2 over 5 is the adjacent over hypotenuse. So sine.
We have to use the Pythagoras formula, right?
I think that's what I was just about to say. Is I'm getting to that. So sine would equal. Okay, so this is what I'm trying. So what I'm getting to. So cosine equals 2 over 5, correct?
Yes.
So we have. So do you remember what I was saying earlier about the SOHCAHTOA?
Yes.
About sine equals opposite over hypotenuse and all that. Do you have that all written down?
Yes.
So what I'm figuring out here is that so the adjacent side is going to equal 2, and the hypotenuse is going to equal 5.
And then
So we have to find what the opposite side is. So what it would be is I'm just going to use O here. So what I had was O squared, because I'm just going to use O for opposite. Does that make sense?
Yeah.
Plus 2 squared, because that's adjacent, equals 5 squared. So we're just using the Pythagorean. Does that make sense?
Yeah.
Okay, so then I get, so O squared plus 4 equals 25, right?
Hmm.
So then O squared, so if you subtract 4 from both sides, equals 21.
Then it's the square root plus or minus square root of 21.
Yeah, but it would have to be plus because you can't have a negative side.
Oh, yeah, that's true.
So it would just be square root of 21.
What is that? Is that less than? That'd be 4.58. But it says it has to be less than 0.
Oh, because, so we found the opposite side. So that would be, so the square root of 21 divided by 5. Because
Okay.
you do opposite over adjacent.
So 0.9165.
Okay, so then that's right, correct?
Yeah, because it's less than 0.
Okay, so how would we write this again? Or how would I just put?
I think what you just did, like where you put, even if you did like x, so it doesn't look like a 0.
Uh-huh.
X squared plus 2 squared equals 5 squared. And then we got that it was positive square root of 21. And then sine is, so that would be opposite, right? So then it'd be square root 21 over 5. So sin A would be, you could even do square root 21 over 5.
Okay.
Or simplify it if you wanted.
Could you simplify that?
Well, if you wanted to use like a calculator and do like a decimal.
Oh yeah. I mean, dude, should we do it as a decimal or should we keep it as a?
I would say probably keep it as like the square root, just
Okay, that's what I was thinking.
the other one was in fractions too.
Yeah. I'm just trying to make sure I read all this workout so it looks or makes sense.
Yeah.
So then a, so 2 squared plus 4 squared equals 5 squared equals.
That makes sense though, right?
Yeah. So I wrote it down just like writing the SOHCAHTOA stuff out. So I did cosine equals A over H, and then I did sine equals O over H, and then I put A equals 2, H equals 5, and I did A squared plus O squared equals H squared, and I did 2 squared plus O squared equals 5, and then just solved it out, and then got O, and then I just inputted it.
Cool.
Coolios.
Awesome.
Alrighty. So use the fundamental identity to write two functions of cosine A in terms of sine. Indicate which formula to use for a given value of A.
Man, I do not like this stuff.
Okay, so the fundamental
Identity.
identity. I'm looking this up in the book. Okay, so it says so the fundamental identity of trigonometry. Sine squared A plus cosine squared A equals 1. So that's the fundamental identity.
Sorry, say that one more time.
So it's sine squared A plus cosine squared A equals 1.
Okay.
Where is the pencil? Goodness gracious.
So we have to use that, or is that one of the identities? Sorry, I'm like,
That's one that's in the book right here.
okay.
Sorry, where did I just put my pencil?
Okay, can we manipulate that one to come up with a second one, or do we need to find?
Oh, it's right here. Goodness. All right, so let me see. So it says to write two functions for cosine A in terms of sine A. Oh gosh, why is this one so long?
Okay, it's not, I don't know. I'm just reading the book. It says to get an identity for, this is an example of sine. It says replace A and B by X in the identity for sine equals A plus B.
Where are you seeing this?
It's in the, I just looked in the book.
What page were you on?
450. There's just an example of it, so I don't know. I'm just trying to make it fit with.
Okay. So those are the double angle identities.
Oh, just kidding.
So the other one I had, oh, fetch. I forgot what page I was on.
Sorry.
Oh, you're good. Identity. So if you go to page 358, that's where the fundamental identity part is. So what I'm thinking here is if use the fundamental identity to write two functions for cosine of A in terms of sine A. So what I'm thinking is if we just set it, so if we just did, so what it would be is cosine squared A equals 1 minus sine squared A. Because they're saying write it in terms of cosine, right?
Yeah.
So my thinking would be is if we did cosine equals, that's what she's trying to get us to do, right?
Yeah, I think you're right.
So one way would be so cosine squared A equals 1 minus sine of 2A. And then use a fundamental identity to write two functions for cosine A in terms of sine A.
So that was one.
Gosh dang it.
I don't know how algebra, like manipulating it any other way though, right? Because the sign for that's all you would do is the 1 divided by sine 2A. Because then that was simplified, you take the square root of both sides.
Trying to see here if there's anything else that we can. Oh my gosh. Use a fundamental identity to write two functions for cosine A in terms of sine A.
Are they saying like, okay, do we need to like just plug in numbers and like solve for it? Kind of like how this, like on the example where it kind of goes through one?
I mean, I would have.
Or do we need to do it just like with like the way it's written and just manipulate the formula?
That's the thing. I just like the question's not very,
It's not very clear, right?
very vague.
So maybe we could do one equation where we did the 1 divided by there and then another one with the actual numbers.
Well, she wants two ways, and then she just says indicate which way you would use if you're given A. So what I'm thinking is we don't really have to solve anything. We just have to have two different. Oh my gosh, why is this so difficult? Let me see what this other one says. So if you go to, no, these are different identities. Never mind, I'm sorry.
I don't remember doing any of like this on the homework yet, but I haven't finished all the homework either.
You're saying there was one?
Oh, I don't know if there was one on the homework, but based on just like the book right here, it's not very clear what she's asking.
Yeah, I'm not understanding this question at all. You have any ideas, Antonio?
I was looking at just above where the formula is, where it starts to talk about the fundamental identity in the book. It says that, hold on, let me just make sure. But it says that sine A equals Y and cosine A equals X. So I'm just wondering if you could just write it as x squared plus y squared equals the 1, and just kind of, I don't know, just put that you move the one of them over. I don't know.
Oh, I think I get what you're saying because it says in here, I'm reading what you're saying. If sine A equals Y and cosine A equals X, then you'd write it as x squared plus y squared equals 1.
Yeah,
You're okay. I think that's exactly what she's asking then.
but I don't know. I guess I'm not understanding even what I'm saying because we're not giving any points, so it's not like we can really solve it unless she just wants us to move one of those, either the x or the y, over with the 1.
Well, if you're looking for sine, then it would be
Then you
y
would
squared equals, and then you'd move the x over, right? Because cosine is the x.
yeah.
So if you're solving in terms of sine, then we just have to put sine on one side equals the cosine plus whatever on the other side.
Yeah, I that's what I think, but I don't know if that would be right or not.
No, I think
I think
that's right. So what I ended up getting, so what I did is I said cosine A equals X, and then I did sine A equals Y. And so what I had is x squared plus y squared equals 1. And then I subtracted the y squared from the one side to the other because y was sine. So I got x squared equals 1 minus y squared.
Yeah.
And then, so those are the two. and then the only way you could solve it if you were given a value for A would you'd only be able to use the first one, right?
Hmm. Yeah, I think that's right, because you'd have to have the first one to be able to figure out the values of X and Y.
If you were
I don't think this is a well-worded question there.
Yeah, so I circled, so I had cosine squared A equals 1 minus sine squared A as one of them. Then the other one was x squared equals 1 minus y squared as the other one. And then I wrote in words, I said you can only use number 1 if you were given a value of A.
I think that's great. I agree with it.
Okay, so that works then.
Wait, you had x minus 1 minus y squared?
X squared x squared equals 1 minus y squared.
Oh, I see. Okay.
Yeah. Alrighty, and that works, right? Does that work for everybody?
Yeah, I think
Yeah.
it works.
Okay. So yeah, so I guess that's it then, right?
Yeah. So I'll put the link on there if you want to do the link and the quiz. Is that cool?
Okay. Yeah, I'll do that, and then I just put our names down and then just put points, right?
Yeah. So our
Yeah.
names have 10 points, and then I don't know what the other two are doing.
You said it's 10 points for each person?
Yeah.
Okay. Okay, so I'll put the link, the points, and then I will scan this real quick and submit it.
Okay. I'll do this and I'll put the link in the Google chat.
Okay, cool. And then just real quick, have you guys done the unit circle quiz yet?
No, I
haven't.
haven't yet.
I actually just got the email that she sent to where to find it, so I haven't seen it, but I do know, like, I kind of have it memorized how it is. I still have to study for it, but I'm not.
Well, she says you can take it as many times as you want, so.
Yeah.
Yeah, it says it's
Probably
unlimited.
taking it like 10 times.
Okay, cool. Sounds good. All right,
All right.
thanks, guys.
Thanks.
Okay.
See ya.
Bye.